Hi, today we're going to keep looking at tree diagrams, but focus on the more exam style questions. So we'll see what are the main type of questions they tend to throw at you in exams. So for this, if the conscription you've got, I think it's 12 questions to try, 12 pages. I want to go through the first 4 as examples, and then let you try the next 8. So first, here we're told that Seb has a bias dice. So bias is basically another way of saying that's unfair. When the dice is thrown, the odds of landing on a 6 will be 3 out of 5. And we can see that already drawn in for us, that landing on a 6 is 3 out of 5. First step, we need to complete the probability tree diagram. So this, pretty straightforward. The important to remember is for this question, each time you roll the dice, that probability is not going to change. So any time you see you will land on a 6, we know the probability is going to be 3 out of 5. We also have the key rule probability, which is that all probabilities must add up to 1. So because these are my only 2 options, they must add up to 1, which means if this is 3 out of 5, this is going to be 2 out of 5. That's the same throughout. Anywhere we see will not land on a 6, that probability will be 2 out of 5. Okay, so that is part A done. Next in part B, work out the probability that the dice will land on a 6 on the first throw, but will not land on a 6 on the second throw. So for this, you basically want to look at your tree diagram and work out what path you're taking. So on our first throw, we land on a 6. On our second throw, we don't. So that's the path we're taking. And whenever you go along branches on a tree diagram, you will always times them together. So for the first throw, the odds was 3/5, and then we times that by 2/5 for the second throw. Times in fractions, we do top times top, bottom times bottom, which gives us 6 out of 25. Okay, example B. Odds that will rain on a Monday is 0.6. So let's throw that in. Monday 0.6 must add up to 1, which means this is 0.4. Next, when it rains on Monday, the odds that it rains on Tuesday is 0.8. So this is 0.8, which means this is 0.2. When it does not rain on a Monday, the probability that it will rain on a Tuesday is 0.5. So if it does not rain on a Monday, the odds that it will rain on a Tuesday is 0.5. And again, these both must add up to 1, which means this is also 0.5. So always make sure that basically all the branches from a tree diagram always add up to a total of 1. So here, all those 3 pairs of numbers add up to 1. Next, work out the probability that will rain on both Monday and Tuesday. So rain both days, that will be this path here, and you will just times those numbers together. 0.6 times 0.8, which gives you 0.48. Next, work out the probability that it will rain on at least one of the 2 days. So at least one, I mean it can rain on one day, and it can rain on both days. So we have a total of these 3 options, where in each case it has rained on at least one of the days or both. And you do the same thing there. So for this path here, I have 0.4 times 0.5. For this path here, I've got 0.6 times 0.2. And whenever you're combining different paths, you always add them together. So plus 0.6 times 0.2. And then plus my other option, which you actually worked out in part A, which is 0.6 times 0.8. Okay, work it out, then you're done. Example C. Okay, this one looks fairly horrendous at first glance, but it's actually a fairly straightforward one when you break it down. So there's 6 coins in a bag, we've got them labelled down here. Laura takes a random coin and keeps it, and then Famida also takes a random coin and keeps it. We want to work out the probability that her coin has a greater value than Laura's coin. Okay? So let's give that a go. So Laura's taken a coin first, so that means her pick is going to be the first branch in our tree diagram. And we have 3 options of coins, 1, 2 and 3. So let's write those down. So she can get a £2 coin, she can get a £1 coin and a 50p coin. And we can work out those odds. £2 is 1 out of 6 because there are 6 coins. £1 coin is 2 out of 6. And 50p is going to be 3 out of 6. Okay, normally when we do the second pick, we would have to do another branch of 3 for each one. However, in this case, we can be a bit clever, and realize we don't need to do that. All we care about is whether my second pick is higher than my first pick. So I'm going to work out what are the odds of getting a higher coin or a not higher coin, because again, it can be the same value, so I can't write lower. So higher or not higher, and higher or not higher. So this really simplifies things down. So the odds that Famida gets a higher coin, if Laura's got a £2 coin, then there are no more higher coins. So that's impossible. And therefore not high will be certain, because you cannot get, these must add up to 1. So if this is 0, that means this is automatically 1. If Laura picks a £1 coin, so she's picked a £1 coin, this £1 coin has now vanished. Looking at what's left, there are there's one coin that's higher than it. There is the one £2 coin higher than it. And there are now only 5 coins left, so it's 1 out of 5. So that means not higher is 4 out of 5. So just to pause there, these probabilities have changed numbers, and the reason is because Laura kept her coin. Because she's kept that coin is now gone, it means there are now less coins left in the bag. Okay, really important whether you read it, because occasionally it will say she replaces it, in which case these probabilities will stay the same. Okay, the last one. If Laura gets a 50p, she's got one of these 50p's. There are 3 coins with a higher value on it, and there are only 5 coins left again, and there are 2 coins which do not have a higher value than it. We were asked to work out the odds that Famida got a coin of greater value. So we have 3 options here. I have this option, I have this option, and I have this option. I need to work each of these out. So here I've got 1 over 6 times 0, which of course is going to be 0. Here I've got 2 over 6 times 1 over 5, which will be 2 over 30. And here I've got 3 over 6 times 3 over 5, which is going to be 9 over 30. And if you add all these together, so again you times along the branches, then anything you're left with after you times along, you will always add together. 0 plus 2 plus 9 gives me 11 over 30. And that was the odds of Famida getting a higher coin, or a coin with greater value than Laura. Okay, that question is a lot more nasty. I made it a lot easier by only writing if I've got higher or lower, higher or not higher coin values. But again, take your time with these questions. Read them carefully. Take your time with your tree diagrams as well. Don't rush it. Last example. This is roughly the same as the previous one, to be honest. Jeremy has 10 socks. He takes at random 2 of the socks. We're going to work out the odds he gets 2 socks the same colour. I'll go this one fairly quickly. So, I have socks that can be red, blue and green. And even though he's taken 2 socks, we're going to assume he's taking them one at a time. Okay, there's no reason I can't do this. It just makes my maths a lot easier. So in each case, he can have red, blue and green. And this time I will do it in full. So we have a lot of options here. And now we're going to work them out. So the first pick's quite easy. I've got 6 red and 10 altogether. 2 blue, 10 altogether. 2 green, 10 altogether. Okay. Now we need to slow down. If you're taking 2 of the socks, that means in essence you are not replacing them. So if I've got a red sock, that means there's only 5 left. And I've got a sock, so rather than being 10 socks left in my drawer, there's only going to be 9 socks left there. I didn't have a blue sock, so there's still 2 blue socks left, and there's still 2 green socks left. And again, sometimes it's worth checking, do these add up to 1? Okay, in which case they do, because 5 plus 2 plus 2 is 9, which gives you 9 out of 9. Then you do the same for the rest, so I just skip through this actually. So I've got a blue sock, which means I've only got 1 out of 9 left, and these top numbers aren't going to change. I've got a green sock down this branch, so there's only 1 green sock left and 9 altogether, and these top numbers aren't going to change again. So that's my tree diagram. Pause if you're not sure what I've done there. Now on to the question. Work out the probability that he takes 2 socks of the same colour. So I could have red then red, blue then blue, or green then green. And just like with the previous example, I'm going to times all my branches and then add up my answers. Okay, I won't actually do this because So I hope that just do it now, and that stuff's fairly straightforward. You have some questions to try. Again, they're all in the link below. They're all the same kind of questions. They will get steadily harder. Okay? Hope that made sense to you. Thanks for listening, and good luck.